We're going to use our graphing calculators for this one again, and if you don't have a graphing calculator, I'm going to show you what you can do with your phone or with the internet that will help you with this as well. So a projectile is launched upward with a speed of 50 meters per second. Its height in meters is given by this equation, which is a quadratic equation, but it has a 4.9 in it, which is not coincidental because it's half of 9.8, and 9.8 is gravity, so it's a realistic kind of problem here. But this would be hard with the decimal to do a table of values, so what we're going to do is we're going to go to our graphing calculator and we're going to type this in. Now the negative button is right beside the enter button. Important that you don't use the subtraction button. Negative 4.9x squared plus 50x plus 10. This is our graph. Now, when I hit the graph button, it's not very helpful. First of all, let's look at the equation. Do you know that because it's negative that it's opening down? So based on what my graphing calculator gave me, it looks like right now I might see like part of this part of the graph. Do you see that I should want to see more to the right to see the vertex? Now, on your graphing calculator, they call the screen that you're looking at your window. If you want to see more, you would need a bigger window. And we can change the window by the window button. So, if I hit the window button, I know that I want to see more to the right. So we're going to really use this X-min and X-max, that changes your left and right, and the Y-min and Y-max, that changes your up and down. So I'm going to change this to 20 and see what happens. So I hit graph again. Oh, now I found, it looks like right now, I'm sort of looking at this part. That's my window, but I can't see my vertex yet. So I want to see higher. So I'll go back to my window, and I'll try changing this to 20. And I hit graph. Is it enough? So I go to my window button. I try 30. And after doing 20 and 30, I'm now feeling that going by 10s, maybe I should go a little bit more. How much bigger do you think I should try? 150. 150? Okay. Y max.
Negative y do 1,000.
And 150. And I hit graph. And sure enough, now I see my vertex. So we know that our graph looks like this. And we're going to get our calculator to find all of the key important points. X-intercepts. Well, one of these you can find easily without a calculator. Of those 4 points, which is the easiest one to find without a calculator?
Y-intercept.
Y-intercept, because it's really easy to plug in 0 for x. Or in this case, it's t. Plugging in 0 for t just gives us 10. So you would not need your graphing calculator to find that one. But our graphing calculator can help us find each of these other points as well. And then I'm going to show you how you can use Desmos, an online program, to find them also. Everything that you want to calculate on your graph is under the Calc menu, which is above the Trace menu. So you see how above your Trace button it says CALC, calculate. So you push your second button and then Trace, and these are all the things it can figure out on your graph. If you wanted to find your y-intercept, you could hit value and plug 0 in for x, and it would tell you. Your zeros are your x-intercepts, so we're going to use number 2. And in this case, our vertex is a maximum, so I'm going to do that first. Let's find our maximum. Push enter on it. Ooh, it's really close right now, but at the bottom it says find the left value. So you move your cursor so it's on the left side of the maximum and push enter. It'll draw a little arrow, and newer versions actually draw a vertical line as well. Is that vertical line to the left of our maximum? Yes. Then it says, what do you want to put to the right? So we use our cursor, we go past our maximum. It doesn't matter, you could go like really far or not so far. As long as you're to the right, push enter, draws another arrow. Is my maximum between those two lines? Yes. So it says guess, you just push enter again. And it calculates that our maximum here is at 5.102. I'm going to do 3 decimal places because that's what you have to do in grade 12. 5.102 and 137.551. That is our maximum. I'm going to go back to that second calculate menu. This time I'm going to find an x-intercept or a 0. Push enter on that. Again, it wants you to go to the left. So I'm going to get close to this one. So if I want to get close to this one, to the left side of it would be over here. I push enter. Is that line to the left of my x-intercept? It is. Then I go to the right side of it. My cursor's gone, but I push enter. Is it in between those two lines? Push enter again, and I get 10.4. And it's going to be comma 0, but sometimes on the calculator it's going to have this. This e to the minus 11 is scientific notation. Negative 1 times 10 to the negative 11, which is basically decimal 0.00000000001. The calculator said, I'm close enough. We know in reality that when we have an x-intercept, the y value should be exactly 0. But the calculator just gets close enough, and it says, I'm quitting. It's probably done a million calculations, and it's exhausted. So it quits. Something else, if I want to go, so I'm going to go second, calculate again. I want to find the other one. But sometimes you're going to be annoyed that you have to hit this button forever to get to the left side. You can also go to the left if you know what our ticking marks are. So if I type in -2 and push enter, it draws the line at -2. Is that to the left of that one? Would you say that 5 is definitely to the right? I over-exaggerated. I could have used 1. Is my x-intercept between those two? Yes. So I negative 0.196. That would be our other one. Now, if you don't have a graphing calculator, or even if you do, you might want to download on your phone. There's an app for this. It's called Desmos. You can look up at desmos.com online, and it is a graphing calculator. And you can type in the equation, and it automatically graphs it for you. And what's nice about this is I want to see the maximum. I can like scroll in and out. I can move my graph around. It's pretty intuitive that way. Look at that. I can do all of those things. Then if you click on the graph, it says, well, it highlights like points that people usually like to find. Oh, you want to find the maximum? Click on it. You want to find the, how quick is that to find x-intercepts, y-intercepts, and my maximum? You can even click on this and say, you want to remember that? I'll write it down for you. You want to remember that one? We'll write them all down for you so that you have them. And they even started color coding them, so if you forgot, oh, which one was this? Oh, it's the green one. So it's really nice that way as well. In fact, on the AP exam for mathematics, the AP exam is on a computer, and they give you access to this while you're doing it. So you can use your graphing calculator, and if the calculator is not working for you, you can play around on Desmos. So very, very helpful program. And now if we go to the questions that was asked in this question, we graphed it. We labeled important things. What is the significance of the intercepts? This one, your y-intercept, happens when time is 0. This is the initial height. Maybe we want to significance. That's our initial height. What's the significance of our vertex? We know that at 5.1 seconds, we will hit a maximum height of 137.55 meters. This x-intercept, That's when it hits the ground. This x-intercept means nothing whatsoever. You can't go back in time. In fact, when it's talking about here, the domain, because it's a word problem, usually domain of parabolas is everything, but here, this domain only makes sense from 0 to 10.4. Because it can't go back in time, and it's not like this projectile is just going to hit the ground and keep digging. It's probably going to bounce, so the parabola is going to stop working at that moment. Same thing with the range. The range will only make sense from 0 to 137.551. Question you can circle on this one. These numbers.